So, come to come again. So, come to your another example of supernode. Let me tell you once again that for DC circuit everything is being explained in detail, right, as far as possible. Let us try to make things fundamentals, our fundamentals should be as much as possible to clear, such that when same thing will apply for AC circuit and even magnetic circuit, your coupled circuit, right. So, you will find magnetic circuit also will be analogous to almost electrical circuit, right. So, at that time all these things I need not explain, because at that time thought your all this concept will be clear, right. So, that is why for DC circuit perhaps I am spending more time and more examples, such that different varieties of examples, such that it will help you a lot, right. And so, now this example your what you call, this is actually taken, it is a super node, because this is your reference node, this row, and its voltage is V0 is equal to 0. So, in this case one your what you call one independent current source is connected here at node 1, a 5 ampere current is actually, this 5 ampere means this current actually 5 ampere current is entering into this node, right. Here is 5 ampere and another 10 ampere current source is there at node 2. So, this means this 10 ampere current is leaving this node 2, and this V1 and this node 1, this is actually node 1, this is actually node 2, these two are non reference node, and in between one voltage source is connected, that means it is forming a super node, right. So, something like this, because if a voltage source is there, it may be 1, it may be 2, does not matter. If voltage sources are there in between two reference non reference node, then it creates a super node, right. So, next move to the problem. So, you have to find out V1 and V2. So, if you look here, this is actually super node, right. So, voltage source is not there, because we have to apply your what you call that your KCL. So, that is why I have drawn like this, and this is actually super node, that which current is entering and which current is leaving, right. So, in this case what we have done it before going to that, so this is actually super node, right. This is actually super node. This is super node, because one voltage source is there in between two non reference nodes. So, in this case a 5 ampere current, this 5 ampere current actually entering the super node, and this 10 ampere current actually it is leaving the super node, and this is node 1, say this is also current leaving the super node, say I1, and this is the current, say at node 2, this is the I2, right. So, if you write down the equation KCL, if you apply KCL at the super node, right, then this 5 ampere current is entering. So, 5 this current is entering the super node, but current I1, I2 and 10 ampere all are leaving the super node. So, is equal to I1 plus I2 plus 10, right. So, this because this I1 also leaving the super node, I2 also leaving the super node, and 10 ampere also leaving this, because it is 10 ampere current source, right. So, it is leaving the super node, right. This is arrow is showing downwards and this is upwards, it is entering. Therefore, your I1 plus I2 is equal to minus 5. So, this is your what you call that I1 plus I2 is equal to minus 5. Now, what is your I1 and what is your I2? If you see I1 here, I1 is equal to your basically V1 minus 0, because this is a datum node, that is your reference node, V0 is 0. So, I1 is equal to V1 minus 0 by 2, V1 minus 0 by 2 is equal to V1 by 2, right. That is your I1. Similarly, this I2 also this voltage is V2, so reference node. So, voltage is 0, V2 minus 0 by 4, right, because this resistance is 4. Therefore, your I2 is equal to V2 by 4, right. That means that if you substitute here, I1 is equal to, say here I am making it here, I1 is equal to V2 by 4 plus I2 is I1 is equal to V1 by 2, I1 is equal to V1 by 2 plus I2 is equal to V2 by 4 plus V2 by 4 is equal to minus 5. Accordingly, you can solve it, that it will be 2 V1 plus V2 is equal to minus 20, right. So, let me clean it, right. So, all these things I wrote for you. So, if you look into this, that your KCL 1, so ultimately it is coming your 2 V 1 plus V 2 is equal to minus 20, right. All these things I wrote, that 5 is equal to whatever I have mentioned there, whatever I have explained there, same thing is written here. So, if you simplify this, it will be 2 V 1 plus V 2 is equal to minus 20. This is equation 1. This is for your what you call, this is for your KCL, when you are applying KCL to the super node, right. This is one equation. Now, let me clear it. Second one is better you come to this circuit. Second one is that you have to apply KVL also in the because of super node, that KVL is also. So, this is node 1. I am making it for you. This is your node 1 and this is your node 2, right. So, here you have the, I told you that with respect to that reference node. So, this voltage actually your what you call V 1 at node 1, this is your ground, whatever it is, right, and this voltage is your V 2, right, this is your V 2. So, this is plus, in between that you have minus plus, this voltage source is there, right, and this is your 2 volt, right, and this is node 1 and this is node 2. So, here if you apply clockwise, you take, that is your KVL, right, then it will be minus 2, then plus this V 2, then here it is minus, right, I told you everything, then minus V 2 minus V 1 is equal to 0, because it is encountering minus terminal first when you are moving like this. So, minus 2, then encountering plus terminal first, plus V 2, then encountering minus terminal first. So, minus is equal to 0. That means your V 2 minus V 1 is equal to 2, right. This is the constant equation coming because of this super node, right. So, let me clear it. So, this is your V 1 minus V 2 is equal to minus 2, or V 2 minus V 1 is equal to 2, right. So, solve these two equations, that equation 1 and equation 2, you solve it, then you will get this V 1 is equal to minus 7.33 volt and V 2 is equal to minus 5.33 volt. Note that 8 ohm resistor, that means this one, note that 8 ohm resistor does not make any difference because it is connected across the super node. So, this is interesting, just go let us go back to the circuit, right. So, if you come to that, the circuit, that one 8 ohm resistor is connected across the your what you call that super node, because this is actually your super node, right. So, 8 ohm resistor actually not making any difference of the voltage of V 1 V 2 whatsoever, right. So, that means it has no effect on this your what you call in the super node, right. So, that is why it is not making any impact. So, anyway, so this is your what you call that one example of your super node, right. Just hold on. So, next one is your example your 3.4. So, determine I1, I2 and I3 of the circuit as shown in figure 3 using node voltage method, right. So, you have to find out I1, I2, I3, but just let me tell you, there is no element here. So, basically this is a common node, because no electrical element is here or here, no electrical element is here, it is a common node. That means 10 ohm, 40 ohm and all 3 ampere, they all these resistors as well as the independent current source all actually connected in parallel, right. So, 10 ohm, 40 ohm, because nothing, no electrical element is there, you have to find out I1, I2 and I3, right. So, in that case, so how to solve this one? Very simple it is. So, and 50 volt source is there this side 3 ampere. So, just for the purpose of this thing, the circuit is rerun and voltage actually this I told you this is actually a single node. So, basically this one because no electrical element is here, no electrical element is simple wire. So, basically it is a node 1, right, only V1, right, and this side is plus your 50 volt and this is your I1, this current we have taken I2 and this current is I3 and this is 3 ampere. So, how to solve it, right, how to solve it. So, first thing is that you have to find out that your what you call that what is the expression of I1, because you have to apply KCL at node 1. So, first you have to find out what is I1. So, if you apply your what you call KCL at node 1, then it is I1, the current I1 is entering, right, and then this 3 amp because it is a single node, right. So, this 3 ampere current also it is entering, right, this 3 ampere current is also entering because it is a single node. I am not writing this, I mean if you make it like this it will be something like this. So, this is the node, this is your voltage source a 10 ohm, then across here also another 40 ohm is connected, right, and here also same thing, a current source is also connected, a current source, it is also 3 ampere. So, this is actually node 1, this current is your I2, this current is your I3 and this 3 ampere current is this thing, right. So, that is the thing, that is a single node, right, it is single node. So, let me clear it, then again I will do it for you, right. So, in this case that means if you apply your KCL here, then it will be I1, this current is entering at node 1, this is 3 ampere current, I mean this is the same thing, this 3 ampere current I told you that all are connected at the same point, then I1 plus 3, these two are your this current are entering into the node 1 and I2 and I3 leaving. So, is equal to I2 plus I3, right. Now, question is how to find out I1. So, just for finding out the I1 I told you previous 2 example also, take this your what you call this separately I am making it for you just for your understanding. This is plus minus, right, this is 50 volt, right, and you have 5 ohm resistance, this 5 ohm resistance, current is your I1, right, and this voltage is V1 means with respect to this reference, this is your reference, that means V1 actually 10 into I2, right, this V1 actually 10 in, but we will not write this, we will make it that this is your make it plus, right. I told you always the reference or non reference you should take plus, this is your V1 voltage and this is your ground, right, circuit is like this. So, this is V1, right. So, V1 is equal to 10 into I2, but we are taking directly this V1 like this, right. So, if you make, then now you what you do, you apply KVL, right. So, in this case what will happen, it will be 5 into I1, this 5 into I1 plus your V1, then encountering minus terminal first. So, minus 50 is equal to 0, right. That means I am writing here, that means your I1 will be equal to 50 minus V1 divided by 5, this should be your I1, right. So, this I1 you have to substitute here 50 later I have given, but just for your understanding trying to write each and everything. So, I1 will be 50 minus V1 by 5. Look, so many parameters are there, so many resistive values, then current source, voltage source. While I am making lighting like this, there is every possibility I can overlook or I can make some error also, particularly numerical values. If it is anything is there, you just when you will go through this video, you please inform me, sir, there it is there is an error. But hope trying to look into each and every parameters are writing, but still there may be a probability, right. So, this is your I1. So, here you put I1, then that means your 50 minus V1 by 5 plus 3 is equal to I2. So, I2 is equal to your V1 by 10, because this is V1 voltage and this is 10 ohm resistance. So, I2 is equal to actually V1 by 10, because reference voltage is 0, basically V1 minus 0 by 10, that is V1 by 10, right. And similarly, I3 is equal to I3 also it is the same node, node 1, it is, I told you it is a node 1. I3 is equal to also V1 minus 0 means the V1 divided by 40, right. So this is your what you call, this is your what you call KCL equation, then you replace it by V1 and all these things. So if this all equation, this is V1, this is V1, this is V1, you can easily solve for voltage your V1, right. So now whatever I have written will go to that, right. So if you look into that same equation, whatever just I said, that I am putting in this form, whatever I have written, you just put it and you will get in the same form, right. Just for the purpose of your explanation, I wrote everything, but you can write it, because there it was writing 50 minus V1. If you bring all these things to the left hand side like this, it will equation will be like this, right. Because your what you call there what I wrote, this V1 by 10 plus V1 by 40, first equation what I wrote, actually it was 50 minus V1 by 5 plus 3 is equal to, I wrote V1 upon 10 plus V1 upon 40, right. If you bring it to everything to the your one side, say right hand side, it will be coming like this, same thing, right. And solving this, you will get V1 is equal to 40 volt, right. So therefore I1, I2, I3 easily you can calculate. I1 is equal to 50 minus your what V1 by 5, so it is 2 ampere. I2 is equal to again V1 by 10, so 40 by 10 4 ampere. Similarly, I3 is equal to 40 by 10 1 ampere, right. So this is your answer, right. Slowly and slowly we will take difficult problem. So here also determine the node voltages and the power dissipated in 5 ohm resistor in the circuit shown in figure 3.10. So this is the circuit, and all the your what you call current directions are marked. This is your I1, this is I1, right, and this is your what you call, this is your I2, this is I2, actually it is a your dependent voltage source, it is given, it is 8 Ix, and this is actually Ix, and this is a dependent voltage source, so it is 8 Ix, and this current is I3 and this current is I4. So before proceeding further, how to obtain I1 here? Here is the same thing, here also same thing, this is your plus, this voltage actually V1, right, this voltage is V1, you make it connection here, this is your same thing, it is a reference node, right. So in this case also you have to apply KCL at node 1, you have to obtain I1 in terms of V1 and this 20 volt, right. So in that case, anyway your V1 is equal to actually 20 into I3, that is your Ohm's law, but here we want in terms of your voltage. So if you apply now in this loop, whatever I told previously 2-3 cases, you apply KVL here, then in this case what you will get? You will get 2 I1, because 2 into I1 plus this plus it encountering plus terminal first, right. Here also if you mark polarity, it is plus minus, so 2 into I1, understandable, right. 2 into I1 plus V1, then minus 20 equal to 0, because it is encountering that minus terminal first, so this is equal to 0. That means your I1 is equal to 20 minus your V1 divided by 2. This is the equation for I1. This way you have to obtain, otherwise you cannot solve, right. So anyway, let me clear it, right. So all these things are marked. So only thing is that you have to apply your at node 1 and node 2, you have to apply your KCL, right, and after that you make it. So similarly your another thing is that this is 8 volt, and here also before going to that, after that directly I will tell you, right. So this is plus, this voltage is V2, and this is ground, means it is minus, this is ground minus, right. So in this case it is also, if you say we move like this, if you move like this, say clockwise direction, right, if you move like this or anti-clockwise direction, the way you want, if you move like this, but just hold on, for simplicity I will make things in that, I will take the loop in the direction of this your what you call this current. So let me sorry. So take like this, then things will be easier for you, right. And this voltage this voltage is V2, right. So, this is minus and this is plus, right. So, if you do so, you are moving, it is taken anticlockwise, meaning is same, right. Ultimate result will remain same. So, it will be 2 into I2, that 2 into I2, right. Otherwise, clockwise if you take, sign has to be changed, that is all. 2 into I2 plus this V2, it is encountered plus terminal first. So, it is plus V2, right, and then your it is encountering minus terminal first. It is a your what you call, it is a dependent voltage source, right. Basically, it is a dependent voltage source. So, if we make it V 0 is equal to say 8 Ix, something like this. It is a dependent voltage source, not current, right. There should not be any confusion. So, it will be then minus your 8 Ix is equal to 0, because encountering minus terminal first. So, 2 I2, right, 2 I2 plus your this V2, because it is node 2, V2 minus 8 Ix is equal to 0. That means, your I2 will be is equal to, right, 8 into Ix minus V2 divided by 2, right. So, in this case, what you can do is, now next you have to find out what the I1 also I told you how to find out, I2 also like this, then your I3, this is actually reference node, reference node voltage is 0. So, directly you can write I3 is equal to V1 by 20, right. This is your I3. Similarly, I4 is equal to your V2 by 10, right, that is your I4. So, all these things I1, then I1, I2, I3, I4, all how to get it in terms of V1 and V2, all these things are explained. So, next is that your what you call, and your what you call, and Ix, this Ix is equal to your current moving from node 1 to 2. So, Ix is equal to V1 minus V2 by 5, because this 5 ohm resistance is here, right. So, V1, so this Ix has to be substitute here, and see how to simplify. So, rest it is given there. So, after that I will just show you the steps of equation and how to solve it, right. So, at node 1 I1 is equal to I3 plus Ix. So, at node 1, if you look at node 1, this is at node 1, just your further this thing. So, at node 1, if you apply your what you call KCL here, it is your I1 is equal to your what you this thing, you have to make it, this is actually node 1. So, just hold on, this is, just let me clear it first, right. Let me clear it first. So, here, right. So, we went to that previous one by mistake. So, here, so node 1, if you apply KCL here, so it is I1 is equal to your I3 plus Ix, this is at node 1, right. And similarly, at node 2, if you apply KCL, then your, because this current is incoming and these two are outgoing, and at node 2 your I2 and Ix entering into the node 2, and this I4 is leaving. So, it is Ix plus I2 is equal to I4. These two equations you have to write. After that, you put in terms of V1 and V2, whatever has been explained, right. So, let me clear this. That is why at node 1 it is I1 is equal to I3 plus Ix. All these things have been told, now you put it here, right. And similarly, your at node 2 I4 is equal to Ix plus I2. So, all these things have been explained and told by blue ink, right. So, just you put it there, and Ix also I told you V1 minus V2 by 5, you have to put it here Ix. So, from equation 2 and 3 we get, upon simplification all these things, we get V1 is equal to 1.6 V2, this is equation 4. Now, solve equation 1 and 4, this is your equation 1, right, in terms of V1 and V2. You solve equation 1 and 4, right, you will get your V1 is equal to 16 volt and V2 is equal to 10 volt, right, and Ix is equal to V1 minus V2 by 5 from that circuit, you will get it is 1.2 ampere, and power it is your I square R 1.2 square into 5, so 7.2 watt, right. This is the power I square R 7.2 watt. So, this is the answer. Right. Next is determine the node voltages of the circuit as shown in figure 3.11. So, you have to find out the node voltages of the circuit. Look, in this case you have one current source here for 1 ampere. That means this current is 1 ampere, this current is 1 ampere entering into the node, right. And next a voltage source is there here 10 volt, and this is your node 3 and this is your reference node. So, here voltage V0 is 0, again and again I told you. So, basically directly actually V3 is equal to 10 volt, right. So, this actually 10 volt, right. So, V3 is given, I mean this is that V3 will be directly you can write 10 volts. Another is there V2, right, and these are the current. So, these are the current I2, I1 and your I3 and I4, right. So, you have to apply your what you call that your, if you apply KCL, say at node 1 if you apply KCL, so 1 ampere current is increasing. So, entering 1 is equal to I1 and I2 leaving the node. So, it will be I1 plus I2. So, I1 plus I2 is equal to 1. This is one equation will come, right. Similarly, if you apply here that your this node that KCL, then I1 current, this I1 current is flowing like this, flowing like this, flowing like this. So, this is your I1 current is entering, right, into this into node 2, and I3 and I4 are leaving. So, I1 is equal to I3 plus I4, right. This is your what you call, and next is you have to find out what is your I2. I2, if you look into your first I1 is equal to this V1 minus V2 upon 5, right. So, it is V1 minus V2 upon 5, this is I1, right. And next one is your what you call I2. I2 will be is equal to, here I am writing I2 is equal to, here it is 2 ohm. So, it is V1 minus V3 upon 2, V1 minus V3 upon 2, that is actually V1 minus V3 is equal to 10 volt, V3 is equal to 10 volt minus 10 upon 2, right. So, I2 is equal to V1 minus 10 upon 2. Then I3 is equal to, it is flowing from 2 to 3. So, I3 is equal to what to write here I3 is equal to V2 minus V3 by 10. So, V3 actually 10 volt. So, basically it will become V2 minus 10 by 10, right. So, this will be your I3. So, if you, I mean these are all the equations. Now, go to the solution. All these things are explained. Now, go to the solution, right. Whatever I said, now V3 is equal to 10 volt. At node 1 I1 plus I2 is equal to 1, I told you. Substitute I1, I2, this I2 also V1 minus 10 by 2, I told you. So, you will get one equation in terms of here 0.7 V1 minus 0.2 V2 is equal to 6. This is equation 1. At node 2 also I told you I1 is equal to I3 plus I4. So, I1 is V1 minus V2 by 5 is equal to V2 minus 10 by 10, I told you, plus I4 is equal to V2 by 5, right. So, this is your I4. So, this is your this is your V2, this is your V2 and this is reference node. So, I4 is equal to V2 by 5, right. So, if you then means if you make it, it will be minus 0.2 V1 plus 0.5 V2 is equal to 1. So, solving equation 1 and 2, you will get V1 is equal to 10.32 volt and V2 is equal to 6.13 volt, right. Now, next one is determine the node voltages of the circuit as shown in figure your 12, that is 3.1 as shown in figure 12, right. So, in this circuit you have a current source here, you have a current source here of 10 ampere, right, and this is V1, this is V2 and this is V3, right. So, in this case also you apply your at node 1 you apply your KCL, right, and similarly I1 is equal to V1 minus V3 by 20, you can find out. I2 is equal to V1 minus V2 by 5, you can do it, right. Similarly, I3 moving from this direction to this direction, so it will be V3 minus V2 by 10, that is you can easily find. Similarly, your I5 will be V3 by 5, right, because this is the reference node voltage is 0, I5 will be V3 by 5. Similarly, I4 will be V1 upon 10, easily you can find out, and this 10 ampere current source is entering. So, if you apply KCL at this point, it will be your what you call, this current is also leaving, this current is also leaving, this current is also leaving the node. So, basically if you apply the KCL, then I1 plus I2 plus I4 is equal to 0. This is at node 1, and all I1, I2, I3 easily you can know in terms of V1, V2, V3 you can substitute. Similarly, at node 2, if you apply KCL, so this all these three current I2, I3 and 10 all are entering into the node. That means here also I2, here they are also leaving, it was 0, or entering also it will be 0. So, some of that thing are 0. So, I2 is entering, I3 is entering, and 10 is also entering. So, I2 plus I3 plus 10 is equal to 0. This is another KCL. Then here if you apply your KCL at node 3, here if you apply a KCL, then this I1 current actually entering into this node, right. So, I1 is equal to, other two current are leaving, so I3 plus I5, right. So, all these things you will be knowing. With this, right, with this, this is for explanation, this is for explanation. Now, all these things, right. So, all these things if you make it, and this directly you can write, I told you I1 plus I2 plus I4 is equal to 0. You now know I1, I2 and I3 in terms of all this. So, this is one equation. Similarly, at node 2 I told you I2 plus I3 plus 10 is equal to 0. Put all these things. This is your what you call another equation upon simplification. At node 3 also I told you I1 is equal to I3 plus I5. So, you know I1, you know I3 in all these things. You get another equation, and then you solve equation 1, 2 and 3 the way you want, Cramer's rule or anything, the way you want to solve it, and you will get V1 is equal to 45.45 volt, V2 is equal to 72.73 volt, and V3 is equal to 27.27 volt. I hope you are understanding this, right. And same philosophy will be applied for single phase and 3 phase AC circuit, right. And so, here if we make our understanding clear, then things will be very easy for your AC circuit analysis. Thank you very much. We will be back again.